Okay, so in Excel Task B, Task 2, it asks us to create a 30-year fixed rate monthly mortgage waterfall, including the date, the principal plus interest, the principal, the interest, the equity, the residual, the value, and the loan to value ratio. So let's create the waterfall. So the principal payment, we'll go ahead and expand this here. The principal payment is going to be the amount of the loan, which was 180. And the interest rate given here is 4.5%. The loan term is equal to the number of years, 30, times the number of months, which is 12. And for monthly payment, we can use an Excel function called payment, where we then use payment, do the rate divided by 12 because it's per month. Then we do 360, and then the present value is 180, and the future value will be 0. We don't need to put the type in, and that gives us our monthly payment here. For the dates, we'll do, starting with January 2013, and we'll just go ahead and go through here for a couple months, and then it's formatted nicely. We can select it and drag that all the way down to December 2042, which is when the loan will be over. And that happens right there, December 2042. So the starting balance here is 180, and the interest payment will be whatever the starting balance is, multiplied by 0.045, because that's the percentage, and then again divided by 12 because it's per month. The principal payment here is easier to calculate after we calculate the principal plus interest. The principal plus interest actually is just equal to B4 the entire time, which is the monthly payment. So that doesn't change throughout. And then the principal payment now can be calculated, and we can use, we'll have to use the opposite of the principal plus interest since it's a negative number, and then subtract the interest payment from that. And that's our principal payment. And then we see minus. Good. And then we see the equity. Equity will be equal to 200, which was the entire amount of the loan, and then you subtract the residual, which we don't have yet, but we'll still put the equation in. The residual here is equal to the starting balance minus whatever the principal payment is. And then the value, since it's stated that it's a 0% growth, the value will be 200 all the way through. That won't change. Now the loan to value ratio can be calculated by taking the residual divided by the value. And that won't change as well. So our new starting balance for the second line here will be equal to the previous residual. It's very easy to see. And then the interest payment again will equal the starting balance times 0.045 divided by 12. And this stays the same all the way down, so we can just drag it down here. And this again will equal the opposite of this minus the interest payment. And there we go. That's the principal payment here. And then the equity, yep, negative principal minus interest. The equity, let's have these go out. Let's format these to go to a couple more decimals here. Let's go 4 decimals there we go. And then the equity will again be the total, which was 200, and you'll subtract the residual from that. Sorry about that. Minus the residual. And we'll put in our residual here, which again is equal to the starting balance minus payment. Minus the principal payment. The value stays the same, 200. And the loan to value ratio again is the residual divided by the value. That's how we get that. So now that we have a second line, I like to do one more line just to make sure that everything's good. So I'll just put these in here really quickly. That's good. And the interest payment will be the starting balance times 0.045 by 12. And this drags down. This principal payment equals equity residual Great, so now that we have a couple lines here, we can go ahead and drag these down. The formulas will go with it. We'll drag it down the entire way, and hopefully the residual equals 0 at the end here. These formulas won't go through until we drag everything down. But if the residual equals 0 at the end, you know it's correct. Right there. Still dragging it down here. See, this one's all the same. Just drag it all the way down. Now we start to see some numbers coming in here. Drag these ones down. First row is a little different than the second and the third row, so I like to just drag the second and the third row down. Then when we drag this one down, we'll start to see if we did it correctly, which hopefully we did. And there we go, look, got 0 in here. That's the important one to see. And then we can drag these values down. The loan to value ratio will go through correctly. Now all the numbers are popped in here now once we got the residual in, because the formulas are all working. Looking good so far. There we go. And look at that. All done here. Residual comes out to 0. Equity comes out to 200. Value stays at 200. And we see the principal plus interest never changes. The principal payment increases as we come down. And that's it there. So now the second part of the problem asks us to calculate the average interest payment over the first 5 years. So we'll just merge a couple cells and do it over here. Get the average interest payment for the first 5 years. There we go. And that will equal, we can just use the average function here, of interest payment up to, it starts in 13, we'll go all the way through to 17, end of 2017. And there we go. That's the average interest payment on the first 5 years. Now, next part asks to calculate the average interest payment over the first 5 years when the interest rate drops by 1%. So the best way to do this is to just copy our first few rows here, and we'll open a new sheet, paste them in. Let's look at this a little bit better. And there we go. So now it's saying that the interest rate drops by 1%. See? So the interest rate will be 3.5 instead. So we see the monthly payment dropped accordingly. And we'll go ahead and change this to 0.035. And this one as well. Oh, undo what we did there. We'll change this to 0.035, and this one will be 0.035. Got all those in right. Everything else stays the same. Nothing else is changing. Let's double check that. First, my interest rate drops by 1%. Okay. And we'll go ahead and we can drag dates down here. First 5 years. That's all we need. So we'll just go to the December 17. We can drag these starting balances down as well. Nice and easy here. Once we've changed this, it's pretty simple. We can see that it's just a matter of dragging everything down. It will all match up again. Since we're only going to 17 here, 2017, we won't see the residual hit 0 this time, but we will see that the average interest rate will be correct. There we go. The residuals coming in. Everything looks good. We don't even really need these over here. We can just start calculate out the average value, average interest payment first 5 years at 3.5%, and that will be equals average of this interest payment here, all these first 5 years, and there we go. That's the average at 3.5%. Now the next part asks to calculate the average interest payment over the first 5 years if the interest rate equals 4.5% and the loan balance is $480. So we're switching the loan balance here. So we'll go back to our let's see, it's a little hard to see here. That's what we did there. We'll do a new one now. And undo. Let's go back to our waterfall. We'll copy this information. Start a new one here. Make it so we can see everything. There we go. And we'll do the exact same thing that we were doing before. But this time, we'll use the 4.5% and we'll change the loan balance. The principal will now be $480. So this will change to 4. This will stay the same. This all stays. That just started at $480 instead. And we'll assume that it's going to be $500 instead of $200, since it wouldn't be a loan on $200. 500. So we'll change all of these to 500.